All right, let's dive right into this explainer and tackle a massive everyday physics misconception head on. Heat and temperature. I mean, you probably think they're the exact same thing, right? Welcome, everyone. Today, we're looking at something so fundamentally woven into our daily lives that we literally never stop to think about how it actually works. We're going to explore the energetic divide between these two incredibly common concepts.
So, are heat and temperature the exact same thing? Well, most of us use these words interchangeably all the time. You might say, turn up the heat, or wow, the temperature is rising, and mean the exact same thing in your head. But today, we're going to break down why they are actually completely different beasts. In the world of physics, these two terms describe completely distinct phenomena, and by the end of this explainer, you'll see exactly how they operate.
What exactly is heat? Let's define what our first contender actually does in the physical world.
So here's the absolute crucial point. Heat is all about action. It is strictly energy in transit. Heat isn't some stagnant property just sitting inside an object. Rather, it's the very movement of energy itself. It's a highly active process. Whenever there's a difference in how hot two objects are, heat is the energy that travels between them, and it is always moving from the hotter environment over to the colder one. No exceptions.
And because it's a form of energy, heat is formally measured in joules. Think of joules kind of like the currency of energy. Just like we'd measure distance in miles or kilometers, when physicists talk about the total amount of energy being actively transferred from one thing to another, they quantify the whole shebang using joules. Let's visualize this with a perfectly familiar scenario. Step 1. You've got a hot cup of tea. Step 2. Energy transfer begins when, Step 3, you drop a cold metal spoon right into it. Boom! You're initiating a real-time physics experiment. The heat actively flows from that hotter tea directly into the colder spoon. You've definitely felt this happen when the handle of a spoon slowly gets warm in your hand, right? Well, that warmth you're feeling is literally the energy, the heat, in transfer, moving from the tea up the metal of the spoon and physically warming up the skin on your fingers. Section 2. What exactly is temperature? Let's move on to our second contender and see how this builds our understanding. Now, rather than being the flow of energy itself, temperature is basically a speedometer. It's a stationary measurement telling us how hot or cold an object currently is. But on a microscopic level, temperature is actually indicating the average kinetic energy of the particles inside a substance. What does that actually mean? Well, if you were to zoom way in on hot water, you'd see its particles moving and jiggling around so much faster than the particles in cold water. Temperature is just our way to measure that average microscopic speed. And unlike heat, which relies on those joules we just talked about, temperature is measured using a standard thermometer and is expressed in degrees Celsius, Kelvin, or Fahrenheit. The everyday scales we see on our weather apps and oven dials. Notice, these aren't telling us how much total energy is moving. They're just giving us a quick snapshot of the hotness or coldness of that specific environment at that exact moment in time. Section 3, the ultimate showdown. Let's put these two side by side, because this is where the contrast becomes incredibly clear.
Let's break down this comparison. Looking at their nature, heat is energy in transfer, while temperature is just the measure of hotness or coldness. But look at that middle row. This is where the physics gets pretty wild. Notice that heat heavily depends on the amount of substance present. The more of a substance you have, the more total energy can be transferred. Temperature, on the other hand, absolutely does not depend on the amount. A single drop of boiling water and a massive pot of boiling water have the exact same temperature, even though their total heat energy is vastly different. And of course, as we discussed, they use entirely different measurement units, joules for heat and degrees for temperature.
So here is how they interact perfectly in nature. The transferred energy, heat, continues to flow until the measurement, temperature, balances out completely. Going back to our spoon in the hot tea, the energy will keep traveling into the spoon until both the spoon and the tea reach the exact same temperature. Once that equilibrium is achieved, boom, the flow of heat stops completely.
Section 4. The bucket versus the cup. Let's put all this into a real-world test to see the difference in action.
Think about these two items. On one side, we have a small cup filled with aggressively boiling water. On the other side, we have a large, heavy bucket filled with just comfortably warm water. Or, if you really want to scale it up, imagine a steaming cup of coffee compared to a massive freezing iceberg. Ask yourself right now, which one has a higher temperature and which one actually holds more total heat energy?
Well, the cup is definitely hotter, so its temperature is significantly higher. The particles in that small cup are moving incredibly fast. But the bucket contains vastly more total heat energy simply because it has so much more water.
Even though the average kinetic energy, the temperature, is lower in the bucket, there are millions upon millions more particles in that giant volume of water. When you add up all the energy from all those extra particles, the bucket actually holds way more total heat energy than the tiny cup. The exact same goes for the iceberg. It might be freezing cold, but its sheer massive size means it holds an immense amount of total heat energy compared to a tiny cup of hot coffee. Crazy, right?
Grasping this simple but profound difference is absolutely essential, not just for passing a physics test, but for understanding how our everyday world operates. So, let's do a rapid-fire recap of our key takeaways from today's explainer. Heat is the actual energy being transferred because of a temperature difference. Temperature is the metric telling us how hot or cold an object currently is. Heat is always the active participant, flowing from hot objects straight to cold objects. And finally, while they are deeply interconnected, heat and temperature are absolutely not the same thing.
Keep that difference in mind the next time you encounter anything hot or cold. So next time that warmth hits your hands wrapped around a coffee mug on a freezing winter morning, ask yourself, are you feeling the temperature or are you actively feeling the heat? Keep exploring the fascinating physics all around you, and I'll catch you in the next explainer.